Hello, everyone. Good morning, good afternoon, good night. We welcome you to this Earth Quality Tech Talk. Today, we have a talk that will be done by Dr. Ajay Nagpure from WRI India. And today we will hear about the emissions inventory and the work that the WRI India team is doing in Surat, India. So I would like our colleague Ken to just tell a little bit about this series of air quality tech talk.
Hi, good morning and good afternoon, everybody. So thanks, Beatrice. So the Air Quality Tech Talk is a new series we started a few months ago. And what we're trying to get out of this really is for us internally at WRI to learn from the experiences and projects that are being carried out either in DC or through our other international offices, so that we can learn the do's and don'ts when it comes to anything related to air quality. So in the past, we've had 2 webinars focused on the use of low-cost sensors, one in Guadalajara and one in Mexico City. And today we're going to be learning a little bit more about emission inventories, so making a little bit of a shift, learning about bottom-up emission inventories to solve some of the air pollution problems. And yeah, that's it. If in the future, if anybody has any interesting projects they're working on or have worked on, I would love for you to get in touch with me if you're willing to present on that.
Thank you, Ken. Yeah. I will just briefly present Dr. Ajay Nagpure. He's the head of air pollution in the Sustainable Cities program in WRI India. He has been working on developing research strategies and conducting research in the area of air pollution and health risk. Before joining WRI, Ajay has been working with the Center for Science, Technology and Environmental Policies at from University of Nagpure. And over the years, work various prestigious institutions in the India, including the United States and Ajay State University, the India Institute of Technology, Rocky, Institute of the Zoological Survey of India. Ajay holds a PhD from Indian Institute of Technology, Rocky, and has worked more than 14 years of the experience in the areas of infrastructure and environmental footprints, air pollution, and health risk assessment. Ajay has a lot of publication, over 30 international peer-reviewed research articles in international journals, including Nature, Climate Change, Environmental Science and Technology, and Atmospheric Science. So we are very happy to listen to Ajay today. Thank you, Ajay.
Thank you, Beatrice. Hello, everyone. So I think today we are going to talk about our ongoing work in Surat. So for Surat, we have a clean air action plan to develop for our Surat city, where we are going to identify the different mitigation actions for the different sectors. So I would start with this slide because we all are aware about the air pollution, but we all know that what is the air pollution. So that is the chemical or the particulate matter added to the atmosphere by human activities or natural events. So why it is important? You know that this is because air pollution is understanding of air pollution is essential for each of us to help to reduce emissions, protect human health and environment. So generally, what we know that we generally assume that air pollution is only responsible for human health. But there are several research coming out and say that not only human health, but it has other impacts like on the water cycle, agriculture productivity, growth, and many other things. So there are For example, I would say like in Delhi, we generally have a severe air pollution episode in the winter, and during because of that, there is a lot of flights delay and the trucks delay and supply chain losses. So you can see that how air pollution is affecting the different parts, like the transportation. That nobody is thinking about, and there is no studies available for that kind of analysis. And if you see the global data for the air pollution, this you know that the global burden of disease every year they publish the result, estimate the health risks associated with the different parameters that include environmental infrastructure, food, and everything, whatever the causes and the risk factors available globally. And this is the figure for India. It shows that air pollution is the third largest cause of premature, no, it's not a cause, it's a risk factor for the premature mortalities in India. So a third means like what are the first two? It's the first one is a dietary risk and the second one is the high blood pressure. So this third, I think this include this 1.2 million people died every year prematurely in India. So that include about 0.7 million because of the outdoor air pollution and zero point 0.5 million just because of the indoor air pollution. This is the combined. So I think, so you can see this extent how air pollution is affecting the human health. And I just wanted to tell you the most, I think the one of the interesting thing, like in India, if you are living in Delhi and having a, like a 100 microgram exposure, and if you are living in Bihar or Orissa, so there would be a high chance of mortality in Bihar and Orissa as compared to Delhi. You know why? Because of these some I think the various infrastructure like the food, better health services and the food and wealthiness. So there is because these air pollution estimation are the attributable proportion. So that's what if you are if you are having high asthmatic mortality in your area, means there would be a high chance of mortality related to air pollution. So this is the, I think these are some to health risk data. But sometimes what is happening in our country, especially in India, when we talk about these estimation, people generally don't believe it, and especially the policymaker and politician. They say that we don't believe in this air pollution estimation because these are the estimated by the foreign organization or use they have used some other concentration response function. That could be true, but if you see this data, so this is the data compiled by the Indian Express. There is a news paper. So they compiled this OPD data, this outpatient department of the respiratory ward of the two hospitals of Delhi. And they found what they found between 2005 and 6 and 6 and 2014, 15. There is a 300% jump in cases, respiratory related cases in Delhi, and this is the data of the one hospital. So you know that sometimes we generally don't believe on that like estimation, but these are the real number, and this is the data for one hospital. So you can assume the extent of air pollution in our country, in India especially. And since we do not have this ground reality or the ground based this OPD data, therefore we are not realizing how dangerous it is for our health and other important factors. So yeah, so I think if you talk about the what are the hazardous pollutant or the most common pollutant, so there are 6 to 7 pollutants like carbon monoxide, nitrogen dioxide, lead, sulfur oxide, ozone, and particulate matter. So these days we all are focusing, most of the countries are focusing on the ozone and particulate matter. So the particulate ozone is the like this ozone is the secondary pollutant, and the particulate matter is the primary as well as the secondary pollutant. So in India, we generally focusing on the particulate matter, whereas in other country like I would say Mexico or man, I think that there are China or some other part of the world. Now they are focusing on the ozone. So these both of these pollutants have different health impacts. So I think, but if you want to control the air pollution, and we everybody wants to control air pollution, so this it is very important to understand the sources of air pollution. to for the better policy implementation. So there are different tools are available for this source identification, and I would say the best available the tool is the emission inventory. So what is the emission inventory? So emission inventory means the kind of accounting of the pollutant released by a particular activity during a particular time. For example, the amount of pollutant released by transportation sector in a particular year, or by industry in a particular year, or household. So so that is called the emission inventory. So for developing emission inventory, what we need a activity data. It means, like, for example, if we want to develop a emission inventory for the transportation sector. So what kind of activities transportation sector is doing? Either they are consuming fuel, and they are driving, means like they are traveling. So either we need to have the vehicle kilometer travel by these different vehicle categories, or the fuel consumption by the different vehicle categories. And by using that activity data, and there are already available emission factors. So what is the emission factor? So emission factor is the amount of pollutant released by the unit activity. For example, 1 kilometer travel of a car release zero point 0.1 gram of CO, carbon monoxide. So what we can do, if we want to estimate the emission from the car for the, I think, I think thousands of vehicles. So first we need to have the vehicle population and how much kilometer they are traveling, and this then multiply by the emission factor. So this is the, I think, a very simple thing. But what is happening? The most of the developing countries do not have these enough data for the emission inventory development. So I will start with this. I think in this slide, what I just wanted to tell you that, because each country is having a different kind of source characteristic. But if you see the India, so these are the most important air pollution sources in India. So that include transportation, industry, household cooking fuel burning. You know that in India, according to the 2011 census, only 27% of the population were using clean cooking fuel, LPG, is the for the cooking, and 67% of the population, as per the 2011 census, were using biomass, which is cow dung, firewood for the cooking. And another important sector is the uh, waste burning. So the waste collection efficiencies in the most of the urban areas of India is around 60 to 80% or 90%. So means like a 40 to 10 to 40% of the waste remain uncollected on the streets. So because of that, people are trying to reduce the waste by burning. That is the another source. And the construction activities we do not have, because air pollution, we do not have enough regulation or the guideline for the construction sector. And the construction sector became one of the leading cause of, I think, air pollution in most of the cities, because the now cities are growing. And this crop burning, you might have seen this type of picture in the recent news for, I think, air pollution news of India. So these are the major sectors. So if you see this picture, this is the picture, because I was working on the one paper and I just wanted to estimate the health risk for the global cities. And you can see this is the data from the 2014 and 15. And so if you see that this picture, the India and China is having most polluted cities of the world. And I think recently there is a one report, it says I think 25 out of top 30 cities are from India. The most 25 or 20 most polluted cities are India. And just for your information, I just wanted to tell you that 99% of the Indian population are exposed to the air pollutant, which is above the threshold limit provided by the World Health Organization. That is the 10 microgram per cubic meter. And 77% of the population, about 70 to 80% of the population breathing the air far above the Indian Pollution Control Board agency's standard, which is a 40 microgram per cubic meter. So means the situation is very bad in India, and I feel that we do not have enough monitoring station. So therefore, sometimes we do not see the data for the from the many cities. So I think so. I would start with. I would directly go to this slide. So looking this air pollution problem in India. So government of India recently launched a national clean air program. So that so in this program, the objective of this program is to stringent implementation of the mitigation measures and proper mitigation strategy for the different sector, and they want to target, at least they want to reduce the air pollution emission about 20 to 30% from all kind of sources by 2024. That is the thing. But you know that this target is, I think they have given to for all the cities, all the area. But the problem is that if you do not have baseline data, how you are going to identify your target or you are going to achieve the target. So I'll tell you that the most of these Indian cities do not have the baseline data. And now we are running toward this target. So if we want to decide any target, we must have the baseline data. So this is the one of the biggest problem India is suffering. So in this NCAPE, they are targeting, I think they have identified about 122 non-attainment cities. So what is non-attainment cities? The cities which are not following Indian air quality standards from last 5 to 6 years. So those are the non-attainment cities, and they identify 122. But 122 is based on the available data. And for your information, I just wanted to tell you that India only having monitoring station in 310 cities or 310 or 20 cities. And we are having more than 4,000 or more than that, more cities. So there are many cities which do not have monitoring stations. So it is hard to say that uh, we only having 120 cities which require immediate attention. I feel that whole country or whole every part of the country require immediate attention for mitigation strategies. So in this National Clean Air Action Program, so what they wanted to do, they first wanted to develop a database and institutional strengthening and the mitigation. Three actions they are prioritizing for the this National Clean Action Program. So uh, I think for and these are the sectors they are targeting for the this NCAPE, and these are the key components they want to cover. That is the air quality monitoring network. And they want to develop an air quality monitoring network for entire country, and I feel that it would take a lot of time because it's not easy task. Extensive plantation, national emission inventory, which we are going to talk about, and health impact studies, action plan, which we are doing in Surat, air quality forecasting system, so where the national emission inventory plays an important role. So these are the some few sectors where the key component they would like to focus on. But the problem is that uh, we do not have enough data set, especially this emission inventory data set. So for the emission inventory, we required activity as well as the emission factor data. And if you see the database of the country, of the different sectors in the country, you'd find there is a very less database available. So and so this is the map of the this is the graph for the Surat, which shows that air pollution level in Surat. The red line is the CPCB standard for the PM10, and the green is the WHO guideline. So you can see the air pollution level in Surat from 2006 to 2018. The situation is not good. So for this study, how I started the study. So first thing what I did, I estimated the health risks associated with the different infrastructure and environmental parameter for a Surat. And what I found, this outdoor air pollution is responsible for more than 1,500 premature deaths every year in the Surat, followed by indoor air pollution, unsafe water, noise pollution, unsafe centers. And these, why I'm comparing these, because it's very important. If you are talking to a city manager, they generally think water is the important problem. So that's what, when you show this type of data, it shows that how important is air pollution. So I started with this figure, I did a calculation for Surat. Then for each sector, you know that there, if you talk to any people in country, they would say there's no data available. But what I'm thinking, we can use the whatever existing data, whether it's a census data or these other household expenditure data, we can use those data and utilize in some creative way to make a emission inventory, which I am doing in the Surat projects. So I'm trying to, I'll tell you the different methodology and the different approach I'm applying for different sectors and how I'm using different data sets, which is because which I think we generally say that there's no data, but we can utilize different data sets for that. So I have to start with the industries. So for a Surat, what I did, so Census of India, every 10 years, they produce the employment data for the different sector. So if we want to understand the a major industrial sector, so instead of going to the pollution control boards or the industry department, what we can do, we'll just simply go to the Census of India data, and we'll see that the city-wise employment data in the different sectors. So this is the data set which I have compiled for the Surat. And now you can see that the textile is Surat having highest employment in the textile. It means this is the textile dominant area. So I think instead, because what we do generally do, we'll go to the industry department, the pollution control board, and they sometimes they don't have data also, or they don't have data in that format, which is I think givable. So that's what we can use this type of data. So just to get the proxy or like the better understanding of the city. So for industry, I did this. And another thing, because most of the time I'll look for the data, and so there is another data set which I found somehow. This is called the economic census of India. So every country do this economic census, and this economic census, what they do, they go to the high resolution level and they ask for the all kind of economic activity, whether it's a shop, industry, and the employment data. So somehow I found that data, the micro data for industry, and I used that data. I just compiled that data and I play with some data, and I use data. And this is the Surat map, and here it shows the number of economic entities per square kilometer, and this is number of manufacturing entities per square kilometer. So this is what I did. I simply use this available data instead of going to the industry or some other people, because it takes a lot of time and sometimes you would not get the better data sets. So I did this, and this data only provides the number of industry and the employment data, how many people are working in that industry. So what I'm doing for this industry related emissions, so there are two survey, two data set. One is the economic census of India, and there is another data is a industry survey. You know, so economic census of India is providing you a employment data. So what I use that employment data, and I use this survey data which provides the energy consumption for each industry type. So by this economic survey data, I got the efficiency or the per employment fuel consumption for different type of industry. And I multiplied that per employment fuel consumption data to the total number of employees for the different industry. So in that way, I got, because I'm working on this is ongoing work. So in that way, I'm going to get the high resolution industrial emission data for any part of the country. So this is what I did. I simply used the two available data sets, which is in because sometimes we need to try to find out the micro data, and by using that data, I'm developing the industry related emissions. But the another thing is that if you estimated the emission from the industrial activity, so but people will ask about the validation, how you are going to validate your methodology. So what I'm doing, I'm also estimating this, because since I got the efficiency data from the industrial survey, and I estimated total industry-wide fuel consumption for different industry at the state level. And I compared the data for the total fuel consumption of the state, which is easily available. So in that way, I might get the 10 to 20% difference from both the data set, and I would say that whatever analysis I am doing, it is having 10 to 20% of the error. So I think this kind of thing is not available in India. So I'm trying to get what I'm doing. So I'm simply playing with the data, and that way I'm getting a better result. That's what I'm feeling, and I just validated this result with the the State Pollution Control Board of the Gujarat, and hi, sorry, I lost the connection.
Yes, Ajay, we hear
Yeah,
you.
yeah. Sorry. So I'll start this household data. What I'm doing for this data set, because you know that the in India the household sector is the one of the leading I think it's a leading source of the air pollution emissions in India, and we generally don't get this household data for from the different survey, and it's very hard to get the data because it's not organized data. So what I'm doing for this, I'm just first there is a data sets available. Every country is doing this household expenditure survey. I know about the United States and some China. So they every year they are doing this household. I think every 2 years or 3 years they do a household consumption expenditure, which provides the data about the fuel consumption. So in India, we are having the similar data sets available. So I went through that data, and from that data, I got this per kilogram of per capita firewood consumption for cooking. So this is the Surat, and these are the rural part of the Surat surrounding area. So I'm just doing this for the grid. So you can see this per capita firewood consumption for the different parts. So I think by using this data, I am able to get the ward-wise information about the per kilogram firewood consumption. I think so. This is the here what I did. So I just for this data set, I got the Census of India data, which provides a household with the different types of fuel, and the consumer expenditure survey, which provide the amount quantity of fuel consumed by the different household. So by using combining two data sets, I got this map of at the ward and village level, which is very high resolution. Similar, so and by using total number of household using firewood, so I got the total consumption of household firewood at the ward and village level, which is almost in the United States, it's a block. I would say the block, yeah. This is the kerosene consumption, which I use this Census of India and the household expenditure survey data. So I got this ward and village level analysis of the kerosene consumption. So by using all these things, I was able to estimate the total PM 2.5 emission from the household cooking. So for India, this is the kind of first work, because most of the time people say we don't have the data, we don't have the data. So I feel that we can utilize these available data source in a more creative way, so that would provide a better estimate for the whatever air pollution sources or the any kind of activity, even the fuel consumption. So this is the household PM 2.5 emission data for this 20 by 20 kilometer grid of Surat. So this is the Surat city, and these are the rural part of the Surat. And this is a PM 2.5 emission in megagram. You can see these high polluted area and the least polluted area. So moving on to the next. So and also like because you know that air pollution is also important for the health risk. So there are some models available which provides, by using those model, what you can do if you have the information about the cooking fuel type, ventilation information of the household, and the cooking hour. So by using those information, you can easily estimate the approximate indoor air pollution concentration, which I did. So this is the household which only using polluting fuel. So if you have the type of fuel information, if you have the kitchen information, whether it's a separate kitchen or the kitchen with the room, and if you have the ventilation information, you can easily estimate. There is a model available. So indoor air pollution concentration, and then by using concentration and the population, you would be able to get the health risks. It's a very simple method. There are some people which are using polluting fuel with they are using primary fuel as a LPG and secondary fuel as a some solid fuel. So I estimate the concentration for those household by some models. So these are the some techniques which we can utilize where we do not have the data, because it's very hard to monitor the air pollution concentration in a different household. So this is the, I would say, the better ways instead of doing a lot of field work. Moving on to the next slide part is the transportation. So for the transportation, because since most of the time we say that there's no data, but some data is available. Like this data I got from this different RTO department. So in Surat, what kind of vehicle categories available? But for India, I just wanted to tell you that India, you would not get the on-road vehicle population. Whenever you you'll go for the data of the transportation sector. Every time they will provide you the registered vehicle population. So the registered vehicle population is a cumulative vehicle population, and if you are using that registered vehicle population data for air pollution emission inventory development or the any kind of emission inventory or energy consumption data, that result would be wrong. So this type of data only provides some kind of ratio of the types of vehicle, but this would not provide you the clear picture. So whatever the RTO department is giving to you, especially in India. So what I did, so what I did, I used two different data sets. First, I went to the Census of India data. So the Census of India data provide the household on the car or two-wheelers, car two-wheelers. So in that way, I got the real number of household having actual two-wheeler or the car. And there is another survey, which is survey, not a census. It provide the number of car or the two-wheeler per household based for the some district level. So by using this census data and uh, household or vehicle ownership data from the census survey, I just got this map. This is a number of two-wheeler per thousand population at the ward and village level. This is, I would again, I'll say that this is this type of data set is not available in our country. In India, we do not have this level of information, but we can utilize data set in different way. These are the total number of two-wheelers at the ward and village level. And this is similarly, this is a car population at the ward and village level. So this is a Surat. So you'll see that rich neighborhoods are having more cars, and these are the urban rural area. So obviously they have less per thousand car population. And Gujarat is sometimes somehow affluent state. So some rural part is also having a more car population. So the total number of cars. So now if you have this car population at the ward and village level, and you know the vehicle kilometer travel by each neighborhood car with the average distance, you would be able to estimate the air pollution emission at this level. It's a very high resolution. So this is the another way to estimate the air pollution emission from the transportation sector. So for that, like this is the average trip length data, which is very important for the developing emission inventory. So how much trip the different socioeconomic group is having for a in a day. Like this LIG is a low income group, MIG is a middle income group, HIG is a high income group. So we can assess the neighborhood with a different income group and will apply those trip length to those neighborhoods. So in that way, we'll get to just the average VKT by the different neighborhoods and the emission at that resolution level. So this is for the transportation. For the transportation, I also developed a model when I was doing a PhD. So this is my model website, which is called a vehicular air pollution inventory model. I have more than many people visit my website from all over the country world. Now I'm having more than, I think, about 50,000 visits. So this is the model which I developed especially for India, where the data availability is the biggest problem. So what I use the registered vehicle population and the phasing out of the age of the vehicle. So by, if you know that this vehicle age, the average age is a 16 kilometer, and you have the registered vehicle every year, so cumulative registered vehicle. So by using those data set, you would be able to estimate the air pollution on-road vehicle population, which my model does. So and this is the I think that now people are using this model in many part of the world. I think this is the my first model which I have developed for India in 2011. Before that, we were not having any model. So what my model does, it estimate the exhaust emission, which is the this evaporation, sorry, tailpipe emission, evaporating emission, the evaporation of fuel, and the non-exhaust emission, the dust wear, tire wear, and other things. So this is the what kind of different variables my model uses, like a vehicle kilometer travel, vehicle ownership, saturation level. So if you want to know the what could be the maximum population of your city, if you want to project the future population of a vehicle, so I use some econometric model. So by using, you would be able to project the future population of that particular area, and the emission factors, vehicle population, and the phasing out age of the vehicle. And by using these variables, I am able to estimate the different pollutants from the transportation. So I'm showing this result for the Delhi. This is the PM10 from the various vehicle categories in Delhi from for different years. So you can see that the contribution of the heavy commercial vehicles is the highest for the PM10. And this is the interesting figure, which shows that that we all are most of the government and the policymakers are concerned about the better technology for the transportation sector, and which we are coming up with. So, but you can see that this is the road dust suspension. We are doing better for the developing the technologies, but for the dust suspension, we are not doing enough. Therefore, you would see more road dust suspension related emission in future, even if you develop a high, I mean, low fuel economy, or like a I think less pollutant vehicle or technology in future. So these are the results from my model. My model required best available data, means whatever data we have, that's based on some simplified data. That model is able to capture the emissions. Moving on to the next sector, this is a construction sector. So India, so I think there is a very less, I think I would say the no study available which estimated the emissions from the construction activities. Because if you go to any air pollution scientists or any people, so they will say we do not have the construction data. How we can get the construction related emissions? So I tried to play with some data, and I was managed to estimate the construction activity emissions by using secondary data, not going to the field, and by using that secondary data, and I also validated my results. So how I did this? So for this construction related data, so every 10 years, the government of India does this census of India. So in the census of India data, they provides information about the number of household with the different types, like whether it's a shop, industry, school, household, non-residential household, all types of building. So what I did, and that is available at the ward and village level. So what I did, first I subtracted the 2011, 2000, sorry, I subtracted 2001 census household census data from the 2011 household census data. So in that way, I was able to get the new household constructed during between these 10 years. And by using this average annual average construction, I was able to get the new household construction between 2017-18 for a Surat. So these are the number of new households. And after that, that it's, again, the second part would be the area of that household. So there is another data set which is available by the National Sample Survey, which provide the average household area for a different socioeconomic segment. So I use the number of new household constructed during particular year and the average area of that household, and multiplying those data sets, I was able to get the total area constructed during a particular year. And then I estimated the material requirement for that area, that area, and also the emission release from that construction activity, because emission factor is available the per square kilometer construction activity. So By using this methodology, I was able to get this emission data. This is the PM 2.5 emission from the construction activities. Again, I'm telling you, this is the first work in India where we have the construction related emissions at the ward and village level. But the question comes, what is the validity of this data? Because the validation is very important. So what I did, I said that I use the construction material for all kind of construction activities. So I compared the total cement consumption provided by the government of Gujarat and my estimation from by using this methodology, and the difference was only 10 to 20%. It means my method is only giving 10 to 20% error. So I think because otherwise, if you want to estimate the construction related emission, it's very hard. You can't go to every building, and in India, we do not have this organized data sets. It's almost impossible to get the construction related activity at this level. So anyway, we have to do some kind of creative uh, thing to get the data. So I just simply played with two data sets, and I was able to get the PM 2.5 emission at the ward and the village level. And you can use this data at any resolution, 1 kilometer and 500 meter or anything. So this data is the ward. Ward is the smallest unit of the administrative village or city administration. So this is the thing which I did. And another part is the municipal solid waste, because for a municipal solid waste, it is almost impossible to get the amount of waste being burned by the people, because you are not going to, you would not be able to measure the how much people waste burning is happening in your city. It's almost impossible in any part of the world. So therefore I thought that I think, because that's very hard, so I thought that I let's think about something. And for that I published a paper in 2015. So what it is, I tried to develop some kind of method, and by using that method you would be able to get the amount of waste being burned in the particular neighborhood. So what is that method? I'll just tell you, this method is here. So this is the simple method. So what I did, so I just walked on the road, street, and I counted the number of burning incidents in the both side of road. So listen, so this I assume that the household or the shop uh, near to that road is responsible for this burning. Means I consider this width and as a rectangle width, and the road length is a rectangle length. So by using length and width, you would be able to get the area. And if you know the frequency of these burning in a particular neighborhood, you'll get the per square kilometer burning, means observed burning incident per day, divided by the total area you covered by multiplying the width and length. So you'll get the square waste burning density. Then again the mass. So for that mass, I did some sampling before the just I trained my eyes that what could be the approximate mass of a particular pile of waste. So in that way, I was able to get the waste being burned at the neighborhood level in quantity. And that is the first study in the world where now my study is used by the African cities and Nepal. I think that recently Nepal has done this analysis for the 20 cities. So I think for Surat we did the similar study. So here I would like to what we did in Surat. So first, what we did, we identify the neighborhood with the different socio-economic and land use pattern for a Surat. So these are the different neighborhoods, and then we design a transit, and we walked on those transits morning and evening, and we recorded the burning incidents. So this is the GPS mark. So whenever our researchers go in the field, I give them a GPS. So in that way, I have that record whether he's walking on the street or not, and it also provide the distance travel and the route of the area. So we have done this kind of transit walk in a multiple neighborhoods of the Surat. So these are the GPS marks. So these are some pictures. You can see the waste burning. And that generally in India, there is a myth. People think that we are generally burning waste for the heating purpose. That is not true. 80%, about 80% of the waste burning in India is for the waste reduction, and only 10 to 20% in winter for the heating purpose. And that is based on the field survey which I did. And these are the picture. This is the rich neighborhood. They are burning waste. This is again the rich neighborhood. People are burning waste. This is a poor slum area. So these are some picture from the Surat we recently we captured during our survey. So you can see the waste burning. It's a very big problem in Indian cities. So here you can see this. They have this solar panel and for the sustainable energy now, and they are burning the waste. And these are the continuous 21st June 2019 and 24th June 2019. Two pictures from the two different days means they are burning the waste regularly. So, and this is the big landfill area where the burning is happening continuously. And you can see that Google can also capture this data. So the Google has captured the waste burning in Surat. So you can see this is there are multiple sources. The industry is emitting, waste burning is happening, and there's a flag of India. So this is a very important problem in India, and we do not have the enough data sets. So what we did, so we simply did this transit analysis for Surat and was able to capture the amount of waste being burned by the different neighborhoods. What we found that high income neighborhood burn about 0.002 kilogram waste per day per capita, kilograms per capita, and the middle income 0.18, 0.01, and the low income goes 0.09. So these are the waste burning estimate we did for Surat. And in terms of the land use, we found that most of the burning is happening in the residential area and then followed by the industry in the commercial area. If you see the socioeconomic status, the low income area is having high waste burning, followed by the medium and high. And in terms of the types of waste they are burning, so they're mostly burning plastic and plastic products, and followed by the paper and paper product, dried leaf. So these are the types of materials. So we were able to estimate the emissions by different components for the city and was able to get this map of the PM2.5 and PM for summer and winter. So this is again the high resolution map at the ward and village level. So these type of analysis would play an important role for developing a high resolution emission inventory and to understand the micro level analysis for a city, which is very important if you are working for a city or if you want to develop a air pollution projection model or any kind of thing. So these type of things which we are doing. But again, the thing is that what is the validity of this method? So for that, one of the next paper, I think another paper which is not related to Surat, but just to validate my method, what I did, I developed another method to estimate the efficiency of waste collection in the neighborhood. So in that, I just simply use the transit method, but each neighborhood I walked and I estimated the amount of dumped waste on the street, openly dumped. And for that, I used 3D technology. This is my picture when I was doing survey. So this 3D, and first what I did, I took a few samples from this waste pile and estimated the approximate weight for that bucket. The bucket is having volume. And volume to mass ratio I found from here by using few samples. And I used 3D technology. So by this 3D technology, you would be able to get the approximate volume. And from here, you got the mass to volume ratio. And by combining these two methodology, I was able to get the total mass of the dumped waste on the street of Delhi. So this is the 3D technology. First time I used it for a waste management. So because 3D generally people use for this statue design or buildings design. So I thought I should use it here. And then for the bigger pile, I use this prism, how to estimate the prism volume. So there's a picture of the Bridgepuri where this recently the riots happened. So I was conducting survey in that neighborhood. So for the bigger pile, I was taking this height, width, and everything. So I used some geometrics and this 3D technology method. So then I was able to get the waste openly dumped on the street. And this is same thing I was doing for all the different neighborhoods. Then I conducted the study in the 4 different neighborhoods, and what I found very interesting, the poor neighborhood is having 67% collection efficiency, whereas the rich neighborhood is having 100%. And then I scaled up this rate data for the entire city, and compare my analysis with the city provided data. They are also providing the data about their waste collection efficiency, because they are taking all the waste to this from the neighborhood to the landfill, from where they are getting the waste collection efficiency data. And I compared my collection efficiency with their collection efficiency, and I found this 5 to 10% variation. Even I feel that I was better. So that's how I was able to validate my waste burning methodology and this methodology. So these are the things which I am doing right now for a Surat and other parts of the India. With this, I would stop. Any questions? Anything?
Thank you, Ajay. Really interesting talk. There were a couple of questions in the chat. One of them was regarding air pollution estimated from cooking fuel data. How do we account for the UJJWALA scheme in which households may have got the first LPG cylinder free, but may not be buying refills subsequently?
Yeah, so that is very important question. So because because there is a recent scheme, but again, in this analysis, what I did, so when I say that multiple fuel use, so the Ujjwala scheme is provided only for the low income people. So for that, you know, that behaviorally they are using multiple fuels, even though they have the data, they have the LPG connection in their home, but they are using for like a important activity. For example, if any guest come to their house, or any for some quick cooking, but generally they use a secondary fuel, a biomass and other things. Here, I would say the Ujjwala scheme is good, but I think we need to work on the behavior change also, because you know that, and again, that is expensive. And also, I found a recent data from some survey, and which says that only the people who are actually refilling data is very less, about 40 to 50%, I would say. And other people are not using that because initially there was no cost for their cooking fuel. There was a zero cost, because they are getting because there is the rural part. That's mostly for the rural India. So they are getting firewood from some nearby jungle or somewhere else. They are picking up, but now they have to pay some amount. So that's what some people are not using it. Yes. Any other?
Yes, there's one more question from Uka. So this is regarding the trip length and car ownership data used to estimate air pollution. Is the trip length by income group from a survey for Surat or Gujarat?
Yeah. So trip length data I have for an income group for a Surat that I have not shown here. So yes, we can have the trip length data for the different income group that I'm thinking to do for a different, because I'm thinking to submit one proposal for the high resolution emission unity, which I'm working with the IMD. So what we have the data for the trip length, not directly trip length, but we have the income group wise fuel consumption for the transportation that we can use for to get the trip length data. So in that way we can get it. So that trip length data is not by income group, but it's like that is for income group, but not for a different vehicle categories. But we might have this data for the different vehicle category for the different vehicle group. So yes, we can do this. Any other questions?
Well, I guess we are getting in our time for the tech talk. We definitely would like to thank Ajay for this great talk. And this is just an example of how high resolution emissions inventories could be done, and particularly being used for the decision makers in a city like Surat. So we are hoping to hear more from the updates and new work that the WRI team India is doing under Ajay's coordination. So this is great. So I would like to thank everybody to be with us, and hoping to have you in the next Tech Talk, Air Quality Tech Talk. Ken, up to you.
Thank you so much. Thank you so much, everyone.